Yes, the weather is also one of the prime topics of conversation in the UK as well. I'd just like to point that out. So thanks very much for letting us come, everybody at Elastic, and talk to you about what we've been doing in the Met Office with Elastic. So we're going to be talking about creating the perfect conditions for deriving value from data. I'm Elinor Woods, and this is Simon.
Yeah.
I'm the product manager in a team called Logging, Monitoring and Alerting Team. We're a small team within the technology area of the Met Office. And Simon?
I'm the senior DevOps engineer in the team.
So I'm going to give you a bit of an introduction about what we've done with our service, the timeline. So we started in 2019. It was a project that came out of an audit, cybersecurity audit, that said basically we needed to get our logs in more of a consistent place, format, and we need to be able to make them available for a year. We were also replacing a service called Laser, which was a Elk stack built on-prem that did do logging analytics. But one of the main lessons learned from that implementation was that we needed to focus on adoption of the service, not just setting the service up, but actually making it able for people to be using it. So once we'd started working on it, we publicised the service, and we have an architecture guild within the Met Office every week where different people will present there. So we talked with the people from Elastic, and they came along and they spoke at the architecture guild along with us to talk about what we were going to do with this service and what we'd already done. That got different areas of the Met Office interested, like from science or observations, in what we were doing, and they were approaching us and saying, look, we're really, really interested in this. Please tell us as your service matures. We've set up new log pathways during 2020, so we get logs from on-prem services, we get logs from AWS services, where a lot of the Met Office software developed services sit, and also from SaaS services hosted elsewhere. So at this stage, we were getting about 200 million logs a day. We sort of thought by the end of 2023, which was kind of the 3-year contract that we had, we'd be up to 1.5 billion logs. Sort of that's what we estimated. During 2021, early 2021, one of our services, so we're in a small team within Logging, Monitoring and Alerting, and we have four different services that we support. One of those services was doing monitoring of our main on-prem platform, where a lot of the Met Office products are hosted, and that service was coming to the end of its license. So we looked at what that service was doing, looked at what we could do with Elastic Cloud, and we decided that we could get the information needed in order to put that monitoring onto this new service that we were building. And that really helped with consolidation. We've got quite a small team. Supporting 4 different services is quite a stretch. So the more we can consolidate, the better. What I didn't do at the beginning was say that we had decided already at the beginning of the project to use Elastic Cloud. Met Office has a strategy of cloud first, so it fitted in with that, so that decision was made. So we use Elastic Cloud to host this service. So during this time, we got up to about 1 billion logs a day, so we were sort of still on track for our 1.5 by the end of 2023, although maybe going a bit higher than we thought at first. So during 2022, as I said, we host a lot of services in AWS that Met Office provides to customers, different information about the weather. And so we started ingest the AWS logs into our Elastic Cloud service. That brought a big spike, as you can imagine, if we've got a lot of cloud services within AWS sending their logs to us, then that brought about a big spike. At that point, we decided we needed to put our logs into different clusters, but it was very easy because we've got Elastic Cloud Managed Service. We can just spin up a cluster and makes our life quite a lot easier. During this time as well, we decided we wanted to do the alerting, we've got IT operations section who support a lot of the services. They need to know if something's not quite right. So we alert to this single pane of glass because they don't want to be looking at all different places to find out notifications of alerts. So we set that up as well. And so now we are very popular. Only last week I had a meeting with a team who are collecting logs from the polar and geostationary satellites. They decided they wanted to send their logs in to us so that they can use the visualizations, analytics, etc., to find out more about how their service is performing. We have found definitely that using Elastic Cloud is key because we are quite a small team, as I said, and actually being able to leave that management of the service to Elastic means that we can focus on what our stakeholders, what our customers need from our service. Now, one of the key concerns whenever you set up a new service, especially in the Met Office, it seems, is what on earth you are going to call this service. It takes quite a lot of thought and conversations about it. So I'm going to hand over to Simon, who's going to reveal what we call this new service.
Very dramatic. Yeah, there's an acronym for everything in the Met Office. So we've called it the class service. It's Common Login and Analytics Service. I thought I'd just basically explain the 5 production clusters that we're running at the moment. We've got some dev ones as well that are spun up automatically by code pipelines, and then they're torn down after we've used them for whatever we're testing for. So the 5 production ones will start with main. That's for our on-premise logs that are coming through syslog or other things like web proxies, firewalls, that kind of thing. We've got some SaaS logs coming in from third parties and also CloudTrail from AWS. We did originally have CloudWatch as well, but that ended up being a lot more data than we originally envisioned. As you can see from the log count down there, that's just for our CloudWatch data. So basically we have around 120 AWS accounts in the Met Office, and we ingest all of those logs. So that goes to about 1.2, 1.3 billion logs a day. So across our production workloads, we're looking at an event rate of about 200,000 logs a second at the moment. So yeah, we try our best. But yeah, so that's the cloud one, that's for CloudWatch logs. Metrics is for metric beat and packet beat data. We use those agents on all of our on-premise production servers, basically, just to get basic monitoring of what's going on with them. Monitoring is an internal one for the team. That's basically your Kibana audit logs and Elasticsearch logs. And we use it for troubleshooting what's going on with our clusters, basically, as it says underneath. And the last one is Storm. That's a specific one for our observations team. We kept that one separate because they, before the class projects, they already had the laser system, which Elinor was talking about. And we kept them separate because they needed to be on a different version of Elastic originally for a few reasons. But since we have brought their version up in line with the others, we're all running 7.17 at the moment for our production clusters. We want to move to version 8, but there's quite a few prerequisite tasks we have to do first before we do that. So that's that. I thought I'd just talk about what our log flow architecture looks like. So I'll start with the on-premise logs. So as you can see on the left, we've got a number of different sources. So from Windows Active Directory, Linux host, and Cisco, or like our web proxies, things like that. They can either go to our syslog server, or they can go through the Windows Event Forwarding server, which eventually comes to Logstash. We've got 10 on-premise Logstash servers to be able to handle all of our transformation workloads that we need. And we've got a dev one as well. We try and push Logstash pipeline development out to the teams if we can, just because time is a very finite resource. Sometimes that works, sometimes it doesn't. It obviously depends what kind of team they are, whether they're more technical or not. We do that through centralized pipeline management on Kibana, so they can literally edit the pipelines there, push it out to our dev Logstash and test it. So moving from there, Logstash pushes the logs into S3. That's for long-term archiving. Eventually, we'd like to move towards searchable snapshots and using the frozen tier, cold tier, but we can't do that at the moment. So we keep all of our logs once they've been transformed in S3, and that kind of provides, like I say, the long-term archiving, but also a kind of cache. So although we use persisted queues on Logstash, S3 also kind of acts as a in between. So new object notifications when in SQS then get received, and we've got a fleet of EC2s, so an EC2 per, or an auto-scaling group per log type in EC2 that picks up those logs that have already been transformed from S3 and then pushes them up into our Elasticsearch cluster. As you can see, as Elinor mentioned, we're running all of our clusters in the Elastic Cloud, so yeah, it depends which one. We are starting to use data streams now as well, but at the moment they're just normal indices, how we're pushing them in with ILM and stuff. So that's on-premise. I thought I'd also show what our cloud log flow architecture looks like. So this is for our CloudWatch logs. So basically, as I say, we've got about 120 accounts. There's a log group subscription that's put in by our cloud team on all of the log groups within each account. And then a Kinesis firehose is used to stream all of that into S3 buckets that are in our account. And that's where it joins a similar data flow to the on-prem ones with using SQS and EC2 to process them. The difference being that Logstash is running on the EC2s as well. So that's where we do our Logstash pipelines for CloudWatch logs. So we do a few different things there. We're using the flattened field type to pull out JSON from the CloudWatch logs. And there's a few specific use cases, for example, of our synthetic canary testing in CloudWatch that we use for synthetic user testing. We pull the data out of the flattened field into their own fields. And so that way it's more, you can do more searches and dashboards and things like that, rather than it just being in the flattened field type. And then we remove it after, as we don't need it anymore. So yeah, that's the cloud one. So configuring our clusters, obviously it'd be good to have a kind of single source of truth for everything and how our clusters are configured. So we keep everything in a repo, so that's our Logstash pipelines, but also our RBAC resources, so your roles, users, mappings, things like that. We use AWS CoPipeline to do basically everything, so it can optionally create the Elastic cluster if it doesn't already exist using ECCTL. Might have been too many C's. But yeah, so we do that if it's not already built. And then from a deployment config that we've written, it's basically just a YAML file with all of the roles and things that you want to put on that cluster. It then applies it all to the cluster. And we use SSO so our users can access the cluster. So based on Azure AD group membership is how they are granted access to the cluster. And we tie that down as far as CloudWatch and CloudTrail logs. You can use document level security to let them only be able to query their AWS logs, basically. That's how we secure it per team. And yeah, that's pretty much all we'll have to say on that. So how do we monitor our own service? As I say, we've now got a lot of log types. It's grown over time. We need to be able to monitor that. I didn't do this on a particularly good day, looking at the top left of that, because that shows our ingest delay for a few different log types. But yeah, so we're doing all sorts of things here. We've managed to use pretty much every type of Kibana visualization over time. So we do things such as looking at, if you see on the bottom left here, that's looking at our on-prem Logstash. So they're load balanced. So are they load balanced well, basically? And also we're running 2 input ports on the Logstash, so 5044 and 5045, and it's just making sure they're well distributed as well. And then we've just got a split of how the ratio of logs that are coming in, and also in the tags. The tags is actually quite a good one because if you suddenly see grok parse failures or date parse failures just suddenly spiking, now it indicates something's going wrong on the pipelines. So that's usually a pretty quick way to see what's going on. And that middle graph is basically an ingest delay over time as well, and covers a few different ones. That's why there's different lines. So it covers the on-prem, AWS ones, etc. This is also, we sometimes add different things depending on use case. So one of the problems we sometimes get with cloud logs is if a team is trying something new, creates a Lambda that's completely runaway and producing a ridiculous amount of logs, that can actually have a detrimental effect on ingest delay, obviously, and it impacts other teams. So sometimes there's one further down, I didn't manage to squeeze it all in, that basically shows who the biggest account, the busiest accounts, basically. So the amount of logs coming in from all of the different AWS accounts. And sometimes you'll come in one morning and a certain team has increased their logs tenfold overnight for CloudWatch, and you're like, we should probably have a word with them. So yeah, it's quite useful for that as well.
Yeah, as I said at the beginning, one of the key focuses for the project we were working on was adoption. So this is a fairly recent, kind of a bit vague because I put team, etc. for teams, but these are the spaces that we have across all of our clusters. So that's 31 because default is always available, and this equates to about 400 different people using our clusters, the various clusters that Simon described. So we use SSO to ensure people can log into these and make sure that they can only see what they're supposed to see, the logs from their own services. We also delegate out ownership of those AD groups. So say, I'm going to talk about digital workplace. So say digital workplace, they have an AD group. They know who they want to be able to see those logs. So therefore, they're the ones that own that AD group and can put people in and out. We don't want to be a blocker as a central team managing all that sort of stuff. So we allow other people to do that. Obviously, we've got quite a lot of class customers here, and we need to be able to inspire them to use class and also support them when they are using class. So how do we manage to do that? So what we've done is we've set up a class user group. So we have demos every 2 or 3 months, and I get people from different teams to come and show what they've done within that demo. Elastic come along to support us at those demos, and they might, at the end of whoever's demo it is, say, oh, have you thought about using, say, machine learning in that way? It would be quite easy now to use that. So we're kind of giving them the ideas of what they can do, what is possible as well. We have a Teams consultancy channel where anybody from these teams can post a query, and usually Simon follows up, or I might just say, I'll go and find out more about that and get back to you. So we always try to follow up as well. We do demos to individual teams if they're interested, like I was saying about the polar orbiting geostationary satellite log people. We met with them last week, showed them what was possible, what logs look like, what the visualizations, etc. look like. We also have a comms site which has lots of videos, how-tos, tutorials. We make Elastic support available, and we also kind of encourage certifications, etc., training, and also things like capture the flag. I know our security team is particularly interested with those type of engagements. So I'm just going to pick up a couple of these, which are ones that have done demos recently at our class user group, and just to show the sort of things that they're doing with our class service. So Digital Workplace did a pilot recently on their remote access technology. Obviously, this is quite key, like lots of people working at home with the Met Office, they changed their technology. And basically, whenever you set up a new service nowadays, you have to send your logs to class. That's part of our service acceptance. It's a security a kind of mandate, really, that we do that. So Matt, who is the person who set this up, he basically said during the user group, we spent so long setting it up because our servers aren't domain joined. It was a real pain in the neck to get our logs in. So once we'd actually done that, we actually wanted to make the use of it. So he hadn't intended using class, but kind of thought, oh, well, if our logs are going in, we may as well. And he said that straight away, as soon as he started using it, he could do things so easily. He could see things across several servers because all the logs are going into one place. Normally, they would have had to log on to separate servers. They could see people with flaky connections. They could see how many people were connecting, etc. So it really made a big difference to them, and they sort of said it was really brilliant that they had that opportunity to show their data in that way. This is the quote that Matt said at the end, and the bit about the impact, almost non-existent. We'd have been unable to see this. Obviously, sometimes you want your service to make an impact. In this particular case, they didn't want it. They want it to be seamless. So they were pleased with what they could see. So another area that has been using Class quite a lot is in the observations area. So they've got 2 clusters that they use, the storm cluster, which gathers information about different nodes. So on the left-hand side here, these are all nodes that are collecting data about lightning strikes. And they're sending the data into one of our clusters, but they're sending the data in as like, I've done my job type thing. So they can see if their nodes are working as expected. And on the right-hand side, you can see this is CloudWatch data that's coming in through AWS, and this is showing lightning strikes across the Atlantic Ocean that you can see there. In order to facilitate this, so this was actually a dashboard. I kind of just grabbed bits of the dashboard, but it's one dashboard that the product manager over in observations has set up. And he was saying, like, he's not particularly technical, but he was able to do this quite easily. And we set up cross-cluster searching for him to be able to get the data that he needed he's sitting on the storm cluster, basically getting the data from the cloud cluster in order to get it all in one place. So what we find is useful is like if we can develop our service alongside the needs of our customers. So once he needed to set up those visualizations, then we're like, okay, you need to have cross-cluster searching set up. We'll build our service to do that as well. This is a quote from Martin. What we find is, as well, if other people, so we're the central team, but if we can get other people to show other teams in the Met Office actually what's possible, then it has a greater impact, I think, from just us always saying it's amazing or Elastic saying it's amazing. If actually other people within the Met Office are realising the benefit of it, that really has a good impact on other people taking up the service as well.
Yeah, so lastly, I was just going to talk a bit about what we've got on the horizon we want to try and do next with the service. So one of the proof of concepts I've been doing recently is using Fleet to manage our on-prem servers. So creating an agent policy, sending that out to all of the on-prem virtual servers, and setting up the integrations we need for that, whether it's log stream or metric data, packet data, etc. Upgrade to 8.x, as I said, we're on 7.17 at the moment. That's something we really want to do, but time, again. I do want to just hit that big upgrade button in Elastic Cloud, but yeah, we'll get around to it at some point. Our security teams are quite keen on the machine learning things that we can do with Kibana, so they're kind of exploring that on their own, which is fine with me, as long as you don't break anything. So yeah, they're looking at that, but we want to take it further, and there's some interesting things we know we can do with 8.x. Some features not currently available. Status and Met Office services and reporting for KPIs, key performance indicators. So as I said, we've been doing synthetic user testing with CloudWatch synthetics, and that's something we can actually tie into our corporate reporting and feedback, so the uptime of our services and availability and just making sure that certain functionality is working. So that's what's on the hopeful immediate horizon for the team.
We said this was what our talk was, creating the perfect conditions for deriving value from data. So I just thought I'd summarize what we thought with how we managed to do that. So using Elastic Managed Clusters means that the team that was within the Met Office can focus on the needs of those customers, hence making the conditions more perfect for them. We've got, as Simon described, robust, reliable, repeatable deployments, automated testing, etc. That means that we can rely on what we're doing and what we're configuring to be actually what people need. We're encouraging self-service. Simon mentioned about the fact that we have the dev cluster that has the opportunity to use centralized pipeline management, so people can transform their logs and get them into a sort of into the fields that make their analysis and searching of those logs easy, and then that can be then moved up to prod once they're happy with that, but that's kind of their job to verify that it's working as expected. We've got our class community. I went through a few different things that we do with our community. That does need nurturing and feeding. It does take me quite a lot of time to actually make sure those people are aware of what's available and also kind of engaging with us and feeding into our demos and things like that. And Elastic support's been really key, both in terms of raising cases to Elastic and kind of getting our problems answered, but also Elastic support in terms of helping us with design decisions, coming along to groups, having a quarterly business review with us where we can raise any concerns we've got, any blockers, and they will always help us. We've got really good relationships with our account manager, Sam, and our solutions architect, Matt. So we're really grateful to that, and it's helped us a lot to be able to build this service within the Met Office.